So when we graph an even-powered rational expression, what I'm talking about are the powers of the numerator and denominator are even. So this is, can you see this numerator is a first degree, and the denominator is also a first degree. Be careful, sometimes these are not necessarily going to be in order. Okay, so what I like to do is I like to make a list of some information that we're going to need. We're going to need horizontal asymptote, vertical asymptote, x-intercept, y-intercept, and our domain. So from the denominator, we get two pieces of information. We get the vertical asymptote in the denominator. So when we set the denominator equal to 0, can you see that I'm going to get 1, positive 1? So that means my domain cannot equal 1. Okay, so if I put 1 for x, I'm going to get 0 in the denominator, and that's bad. But my vertical asymptote is actually going to be that value, so x does equal 1. So I'm going to go ahead over here on my graph, and I'm going to do a vertical asymptote. It's this invisible vertical line, remember? My horizontal asymptote now, that has to do with heaviness. So because the powers are the same, then it's simply the leading coefficient. So I have 3 over 1. So my horizontal asymptote is 3 over 1, which is just 3. Sorry. So I'm going to write y equals 3. So if I go over to my graph, I'm going to put a horizontal asymptote at y equal to 3. Okay, my x-intercept, y-intercept, that has never changed. It never will change. It's always how we find x and y-intercepts. To find the x-intercept, I simply set the equation equal to 0, because remember, this equation is really y equals 2. So when I have a fraction, all I really need, if I want my fraction to equal 0, I'm really just looking for the numerator to equal 0. So when I set my numerator equal to 0, right, I'm going to get negative 6 over 3, which is negative 2, right? So this is going to be, negative 6 over 3, which is negative 2. So I'm going to have an x-intercept. I'm going to put that on my graph at negative 2. My y-intercept is where I stick 0 in for y, right? So if I plug 0 in the numerator, I'm going to get positive 6, and 0 down here, I'm going to get negative 1, so that's going to be negative 6. So that's going to be way down here. That's going to be my y-intercept. So now, can you see that I have 4 sections of the graph? 1, 2, 3, 4. See, 1, 2, 3, 4. So all I'm going to do, I can clearly see that part of the graph is going to go, it's going to go through these 2 points. So all I want to do is I want to approach the asymptotes on both ends. So if I draw this line, I'm just simply going to go like this. Just, it doesn't have to be real specific. You just want to make sure you're just going through these 2 points, and that at the end behavior, you're getting close to those asymptotes in this quadrant. So now the last thing I need to do is there is going to be another part of the graph. It's either going to be up here or down here, and we don't know yet. So all I need to do is I just need to evaluate a point to the right of this vertical asymptote, right? So I had a vertical asymptote at 1. So if I pick positive 2, and that's just a little t-chart, right? So if I pick positive 2 and plug it into my original equation, I'm going to get 12. So we're going back into this original equation. I just simply plugged 2 in for my x values, and I got positive 12. So you can see that that value is going to be like way up here somewhere. So now, again, all I want to do is I want to go through that point and approach those asymptotes. And that's as good as it needs to get.